After learning what an enumeration is and how it can be used in Unreal Engine, in this module, we'll see an example blueprint that will change its animation and the way it receives interactions from the user based on a couple of enums. Starting inside of the first-person example map, let's jump right in and press play. There are 4 sections of the same objects. They all inherit from a parent that contains animations for us to interact with. Let's walk over to the first section. The objects say their activation type is touched, and the animation type changes by object. Let's see what happens when we touch one of them. And in this case, touched means just bumping into them. I'll walk up to this one that says spin. When I bump into it, the animation started and it's spinning. What about when I shoot this one that says vibrate? Nothing. Okay, so apparently it can only be activated by touching it. I'll try one more up here and bump into it. Its animation type is set to drop. It appears that it started to simulate physics and has fallen off this edge. Okay, what about the next section? Let's walk over there. These ones say activation type is hit. If I bump into this one, nothing happens. What if I shoot one? Yep, that activated the spin. And this one is now vibrating. Okay, let's walk to this next section, and they say linked with BPI_COM. If we press the left shift button, a simple hood will be spawned and added to our viewport. These objects are waiting for a call from the provided Blueprint interface. Let's select one of the animations and press activate. I'll choose drop and I'll press activate. And there it goes. Let's try another. I'll choose spin. Okay, cool. I'll press stop all and they've all stopped and returned to their original location. All right, I'll walk over to this last one, and these ones say linked with event dispatcher. But this one in the front says hit. Okay, I'll shoot this one and yep, all were activated as soon as this one started. Let's stop the simulation and select this one up front and change the E activation type to touched and press play again. I'll take another shot and of course nothing happens. But if I bump into it, all the objects that were waiting are now animating. Okay, let's stop playing. Select one of the objects and look at the details panel. There are a few options we can select: the animation style and the activation type. In the advanced display, there are 2 additional options for more specifics. We can set destroy when finished and call ED for event dispatcher if desired, and set a value for the actor to wait for. If actor to wait for has a value and E activation type is set to linked to event dispatcher, it will start when the actor we're waiting for starts. With one of the objects selected, press Ctrl B to find it in the content browser. This first asset, BPP animation, is the blueprint that contains all the data and the animations. BPP is for blueprint parent. It's a way that I like to indicate that this object is primarily used as a parent blueprint. BP interaction cube and BP interaction sphere both inherit from BPP animation. What I'm saying is, all these objects in the scene inherit from one blueprint. They all share the same mechanics. We've built one blueprint and used it in 4 scenarios with 4 different animations, all controlled by the value of a couple enums. While this example may seem a little removed from a real-world project, we can use this technique to open a door when a user approaches it, turn on a group of lights when a switch is pressed, or change the color or texture on an object when the user presses a key. Demonstrated here is a way of creating one blueprint to handle many scenarios to make our scene quicker to build and easier to manage as the project grows or changes. Now, let's open those widgets and see how those have been built. Inside of the UMG folder, open W User Hood. Select the combo box string. Instead of updating the available options for a user to choose in this combo box, we can simply use an enum to populate it with data. So if anything in your project changes, it will be updated automatically. Open the event graph and we'll start from the top. At event construct, we are first clearing the options just in case we had one set in there for sizing. Then we created a for each loop specifically built from the Enumerations style. These are automatically added to the available blueprint nodes for us to develop with. Right-click in the widget blueprint and type Enumerations style. Here we can see all the nodes that are now available pertaining specifically to Enumerations style. This for each loop will run once per enumerator, providing the value of that enumerator. We can convert the value to a string and provide it directly to our combo box. At completed, we are getting the 0 index of the enum asset, which in this case is none, and setting it to the currently selected option. This is so the combo box starts off showing a valid option. The only reason that it says none is because that is what we typed into the enumeration asset when we built it. It can of course be anything. Pan down to the onSelectionChanged event. It will return the currently selected item as a string, and we can use another for each loop to check which option is selected using a branch, then set this new value for the variable EnumerationStyleChosen located inside of the W button main. You may have noticed we are providing this to W button main, but not to W button main 1, which is the stop all button. Open W button main and pan to the onPressed event. After we get all the actors with our BPI-COM interface, we use a switch node based on the value of eButton action. If it is set to Start Animations, we send the value of EnumerationStyleChosen to all the actors that were listening. If eButton action is set to Stop All Animations, it simply calls the Stop All function. So it never uses the EnumerationStyleChosen variable. Using a switch node from an enum can change the flow of logic based on what is needed. Again, by us setting the button to Stop All Animations, we not only change the text written on the button, but also which function it will call when it is pressed. In this module, we learned a couple of examples of how enumerations are used to create a variety of mechanics based on specific interactions. While taking place using basic shapes and abstract animations, they demonstrate that we can create a simple and reusable system to assist us in our projects. We also dove into UMG to see how we can use enumerations to dynamically build our widgets and how they communicate with other actors. Next, we will see a more accurate use case for these techniques and then open the Blueprint editor to dive deeper into how we can take full advantage of enums using blueprints and a scene component.